have developed. And other things are like, okay, ultra precision diamond turning machine, which is developed and supplied to Bark. And also the technology has been transferred to ACE designers. Then we have indigenized for the aerospace. The leading edge slat actuator is indigenously developed and it is flying in the aircraft now. And developed second line test rig. Second line test rig is for PI checking of all the hydraulic LRUs before mounting to the aircraft. Around 90 plus LRUs will be tested by using this second line test rig. Then there's the smart foundry. That's a IoT enabled system. I think Narendra will be explaining in detail about that. These are all the this is a 1010 mixer what you see here, and that has been handed over to ISRO. And this is the in situ weld cutting is for Bark, for cutting the shell in the nuclear power plant. And this is the stud tension equipment developed for Bark. It's for removing the cover extractor. And this is the aluminization process we established. And this is a tin screw extruder. It's a continuous mixer. Continuous mixer we developed and supplied to HMRL. And these are all the other versions like 2.5 ton to the 4.5 ton various capacities of mixers what we have developed. And this is one universal controller for high speed wrapper loom we have developed. It's the 20% of import cost we have developed. And this is what vision based inspection system we made it for the textile machine roller production line. And what you see here is a scanning system. It's a scanning system. Bottommost one is a scanning system. This handheld scanner it is. And this is about the aerospace lab activity. In aerospace lab, we will be developing hydraulic LRUs. This is the bottom one. What you see is the pump, axial piston pump, pressure combined axial piston pump. The other one is the gear rotary actuator. So there are different developments we are doing. And coming to the development of test rigs, these are the test rigs what we developed for PI checking of all hydraulic LRUs. Then we do qualification testing of LRUs also, both environmental tests or endurance. All this test will be carrying out. Some special test setup. This is what vibration testing of axial piston pump in active mode in the vibration shaker. That's all. These are all some what is that ambitious test or like which test will there is no clue for how to carry out. Those things will be carrying out in our place. These are some developmental activities what we have carried out for and this is about the additive manufacturing activities. Like this is the first, I can say powder metal DMLS system is the first installed in CMTI. It's installed in India, it's in CMTI. And later we have even direct material deposition machine also. Then later we have developed so many systems. Like one is for 3D printing of the rubber, and that's we call the Sukshma. And IoT enabled 3D printers, that is it's under progress now. There's so many. Then after pre-processing, there's a IFM machine also we have developed. Then we have technology like these are all like for R&D support. We have different schemes called Industry Accelerator Program. It's a Ministry of Heavy Industries program. Here the 80% will be contribution from the government side and 20% support will be from the industry partner. So we had two activities, like one for the machines and automation, and another one is for aggregate for capital goods machines. So in the machines and automation, we had developed 8 product and with 8 industry partner, and around 37 associated technologies has been developed under this scheme. And similarly for aggregates for capital goods also, the technology we have developed, 8 technology we have developed, and with the 7 industry partner, and associated around 31 associated technologies also we could derive from these things. These are all the various technologies we have developed. What you see here is the winding machine. And this in detail it will be explained in the coming slides. And this is the IntelliPod for the data acquisition system. And this is like a nano spring, like it's a spindle, ultra precision air bearing or a rotary spindle. And there's the industry leak test panel also we developed under this scheme. There are two principles, like one is based on the delta P or by measuring the leakage in terms of by mass flow control. So then these are all the various development. This is one what do you call DED lace, I mean additive manufacturing, like okay, by DED machine we are developing. It's for 1.5 meters of capacity. It's under progress now. Then coming to the smart manufacturing, my colleague Narendra will explain in detail. Yeah.
Good afternoon, everyone. Myself, Narendra. I'm heading the Smart Manufacturing Group at CMTI. I think last 6 years people are talking about Industry 4. I will be just showing what CMTI is doing in smart manufacturing. So, as the Government of India has initiated a program called as Samarth Udyog Bharat 4.0. Basically, Industry 4 was originated from Germany as a government scheme as Industry 4.0. That's why in US they call it as digital transformation. Likewise in India, started a program called as Samarth Udyog Bharat 4.0. 5 institutes have been identified: IISc Bangalore, CMTI, IIT Delhi, IIT Kharagpur, and C4I4 Lab Pune. Many are academic institutes. They are focusing mainly on MTech and PhD programs, and also they are also working with research projects. CMTI, what we have done is we have created one smart factory, and we have created about 8 laboratories on technology pillars of Industry 4.0, where MSMEs can come and see what is a smart factory. So you can see the facility where we have a facility where we have a mix of legacy machines, old machines, and latest machines. Now when you come there, you can able to see what to do with the latest machines, because in the latest machines it is easy to get the data from all these latest controllers, but the challenge is what to do with the data. You get thousands of parameters. So where this data can be used, for which applications, that kind of use cases you can see. Then from the old machines, maybe few parameters you can extract. Through that you can do few information, that kind of use case you can see. Then you also see where robots can be used at different applications. Then when we looked at the Indian context, when we started this activity, the main challenge for industry was implementations and benefit out of those implementations. When we took one solution from one of the MNC, there they charged about 3 lakhs for one energy monitoring solution. If you go to MSME and say that you buy this energy monitoring solution for 3 lakhs, he never buy it. The reason is, for 3 lakhs he can buy one conventional machine and he can produce some parts and ROI can be justified. When you talk about a software or hardware for such a requirement, it is very tough to convince MSMEs to adopt these technologies. So then we looked at how to tweak these MSMEs. Then we came out with a similar solution for MSME, where we have connected 8 CNC machines and we are offered for just 32,000 rupees. And we have implemented with one of the MSME in Bangalore itself. So later we looked at other aspects. Then when you look at larger enterprises, those people are again looking at bigger platforms like Bosch, or Siemens MindSphere, or Azure AWS. Then we are looking at, can we make those kind of platforms in our country and can we take it to industry? Then we deployed these solutions in Toyota Engine Division, that is mainly for real-time maintenance monitoring. That kind of solution we have done both GD plant, global diesel plant, and high rider engine plant. Then we also looked at other challenges in welding. So today the theme is on quality. Is it that always quality is high-end technologies only we should put something like 3D scanners or in-process gauges? there are simple techniques are available. Just by monitoring current itself, we can able to help on the process side for the quality. So we have deployed one solution for GERB, that is weld monitoring system. Then we are establishing smart factory in one of the academic institute in Ranchi. Then even HAL we have proposed the same. So these are, I think we also developed for one of the, I think sir was talking about manufacturing execution system. Actually what digital transformation can bring to the manufacturing industry is, already many organizations have adopted with ERP systems. Some have been adopted with PLMs. And today people are talking about IoT platforms. And some are talking about manufacturing execution system. The real thing about digital transformation is we don't require all these platforms actually. One single platform can bring all these activities in the entire enterprise. That is what the digital transformation is going to do it. So that level of product, it is going to evolve, and that is the that is maybe all these gaps. Once everybody starts maturing this IoT platforms, then MES and ERP, then one single platform only will be going to happen in the coming years. So what we have done for BEL, we have implemented one manufacturing execution system to one of the SBU. Now we are also, they're also signing MOU with CMTI for deploying these solutions in most of the DPSUs. Because when we go to any DPSUs, nowadays everybody is going with the implementation, but the cost for implementation is in 10 plus crores. So which is very tough to generate ROA until unless if it is addresses the pain points in their manufacturing lines. So then we also working on development of cost estimation software. I think one of the person was asking, is there any automation software where can we estimate the cost? Yeah, for estimating the cost, I think for MSMEs, maybe if you can describe your activity, what you are doing it, there are simple softwares available. Within no time you can able to do it. I think the way the startups are emerging, you can go to any startup, need not to be institute like CMTI. For 10,000 rupees, they can able to develop a software where you can, without manless quotations can be given based on your pricing only. You just tell what is that your pricing strategy, they will only do it automatically. Then what we are developing is, there are some imported or indigenous developments are required for high-end cost estimation requirement like composite manufacturing, then sheet metal and machining. There we take information from CATIA or STEP files. Then we try to bring this costing factor. That is with ADA we are doing it. Then we also brought one solution for Booler. That is, I think whatever you are using apps, mobile apps like Ola, Uber, Zepto and all, they're all for e-commerce industries that is going. Now the same concept, why don't you use it for supply chain of your industries? So for industrial engineering, we want to bring this concept. So where people are using mostly milk run concept. So how to utilize this vehicle very efficiently, how space optimization using grid optimization techniques, and how quickly you can plan and you can bring the transparency across your procurement teams, logistic teams, even to the driver level. We can have that level of simple applications. Then with the Tata Power, we have worked on AI-based inspection system, mainly for solar panels, where earlier a person was standing and he used to check all these 108 cells in a solar panel. So it is a time consuming, and moreover, if the person is not so attentive, it is very tough to, otherwise it pass that quality check. And 25 years that warranty will be there. If an item returns back, it is too much loss to the organization. So we have built one AI-based quality inspection system. Then we also developed a software similar to MES, where a lot of data get generated, and this data should be stored for 25 years. I think now we are working with Tamil Nadu plant also, Tirunelveli, where they get petabytes of data. This should be stored for 25 years. So these are some of the solutions. So apart from just software and embedded related solutions, we also build smart machines. So initially when there was a DST program, multiple organizations were there. They wanted to develop a smart foundry machine. So we have developed a smart foundry machine. Now it has been supplied to NIMT Ranchi, wherein 3 operations are integrated into a single machine. One is a 3D printer. You will get a pattern, something of that. Then we have a melting and pouring unit. You get a sand, you have a sand molding unit. You get a sand mold. Then you have a melting and pouring unit. You get a casted part. When you go to any foundry facility, you will have a larger facility. Whereas in this development, in a 10 by 10 square feet area, how we can bring this kind of foundry system, we can build it, that we have demonstrated. So we also worked on digital twin with 3D holography systems. Then we also transfer this one of the technology that is for old machines, how to make them smart. We developed an edge device. Even you can run AI models into this device. Then this is one solution we deployed in GERB, where IT and OT solution and very affordable cost, how we can able to increase the quality just by monitoring the current. Then this is I was talking about for MSME. So for one of the MSME, it is not just monitoring the energy. We are monitoring the energy, and with that energy we are converting into the productivity of each machine. And then he started thinking about giving incentives to the operators. Then for BEL, whatever I said about manufacturing execution, all these modules have been integrated, starting from order management, process planning, where in this process planning and scheduling, we brought dynamic scheduling, because in the manufacturing, what happens is, it is not just machine goes to breakdown, the operator also plays a role, and then sometimes raw materials. So software checks all this and automatically it schedules, and dynamically it will shift the schedule also. So then we brought quality module into this, apart from production monitoring, like what others are dashboards people are talking about, OE and all. We brought in-process inspection in the line, and first article inspection, all that we brought it in the system. So then many times people will ask, when you invest 1 crore or 2 crore for a deployment, how a ROI can be justified? So the director of BEL, what he told is, we charged about, for this solution, we charged about 70 lakhs. So he told that in weeks time he will be getting the ROI. So even I also felt, in government institutes, what will happen, the data will be available with multiple groups. Some data will be with the design team, some data will be with the methods group, some data will be with the production team, and the quality data will be with the quality team. So there are a lot of silos are there. That can be easily addressed. Transparency we can bring, accountability also easily we can brought in. So finally, what I felt is, all the document, one simple document management system, what is available in this module, that itself is a ROI for this solution. Last 30 years, whatever they produced it, all data are there in a single solution itself. So this is what we deployed it. So this is one of the SBU we have done it. Now we are going to do in advanced different naval systems in BEL, and we also got few more requirements from Chennai, BEL Chennai. So I think morning somebody was telling about auto ballooning software. So we also developed a quality management system where it does, you can give the CAD model, so it will do auto ballooning. Then it has another feature where you can connect wireless devices, or you can also connect to any other industry protocols, whether it is a Modbus, a TCP/IP, or Profinet, Profibus. As long as the OEM is accepting protocols, we can connect any types of CNC controllers, robotics controllers, or any other embedded controllers. We can connect it. So one is, it has 3 features: auto ballooning. Then it has, with auto ballooning, you get the complete inspection plan, it will be generated, and then it can connect to real-time instruments. Then it will also generate the report. So those who doesn't know this solution, generally I think if you go to some industries where they're keeping women's, because they'll have a lot of patience to make a note of all this dimensional information. In a single click, we can able to generate all this dimensional information. And then what we are main focusing is, apart from just doing this, this is good for where your multiple vendors are there, where your inward goods inspection you can use it, and final inspection also is possible. But the real practice in manufacturing industries, it is varies from one industry to other industry. HAL follows some practice, BEL follows some practice, and Toyota follows some other practice. So the real challenge is you need to always tweak the solution and you have to customize based on the manufacturing practice. So in such case, we have to a standard solutions where you buy from other country, the solution providers sell it to you, you don't get any value. So the real value comes, maybe if not CMTI, you can go to any startups, tell your real problem. You can come to CMTI, even wherever standard solutions are there, all can be used by MSMEs. Even for MSMEs, we are ready to give 50% discount if you have MSME certificate for all these solutions. So this is what we brought in BEL, where a supervisor will be creating the plan. Then based on the operation at 4 or 5 stages, the operators can measure without, earlier they were manually entering, now they have Bluetooth devices across. Then whatever the template has come to him, the same thing he'll measure it. Then automatically supervisor, first article pass, everything he can do it. Then the report will be generated. So for a Toyota, what we brought is, Toyota is following 2 practices. One is a time-based maintenance and the real-time maintenance. So what we have delivered to them is a real-time maintenance monitoring solution, where 17 parameters we are monitoring from each machine. So earlier the practice is a person goes to each machine, make a note of those 17 parameters. That 17 parameters in each machine, 10 axis means 170 parameters. Likewise, they have 88 machines. So around 17,000 parameters has to be make a note. So it is a waste of time because his expertise is a maintenance. He should not make a note of all these parameters. So we had come up with a simple solution somewhere in 2022, where a maintenance person sits at one place and then he can directly see whatever the anomaly is there. So if it is critical, he will go and address. So earlier practice is operator tells to production supervisor, supervisor tells to maintenance engineer. This is a waste of time. So these are simple practices. Even I think a lot of startups are there. Only thing is MSMEs, because my own student who did MTech in CMTI, when I ask him, why don't you take these solutions? No sir, we are busy. So the mentality of MSMEs they are busy with, they are stuck with their own cycle. There are wonderful solutions are there for manufacturing, but there are some real pain points are there in MSMEs that maybe I think some people are asking for 2D drawings to 3D, 3D to 2D. That also will come in coming years. And then some people are asking for good programmers. So that is also is possible. And then some people are asking like strong LLMs. So that I think in next 3 to 4 years, I think all of you will, whatever pain you have, all will be solved through technology. Only thing is you should be open to connect with institutes like CMTI or like IITs or IASC. You will get some, whenever programs are there, blindly go with an open mind. Even if you are so busy, you just go and attend once in 6 months, you please attend this kind of events. So you will get some knowledge actually. So then this is what we developed for ADA, that is a cost estimation software. So this is for the Buller. You can see that all the orders, whatever procurement teams gives, the logistic team will be seeing, and these orders, the live tracking can be seen. All the orders. Now there are 5 vehicles have been assigned. All 5 vehicles, whether it has gone to the vendor, that status can be seen. Then what it is carrying also we can see it. So here what is the beauty what we brought is, one is a vehicle selection is automatic by the software. Vehicle routing is also does by the software. Costing, everything is does by the software. Then we are bringing the traceability. Earlier, whenever procurement team tells to procure an item, whether the vehicle has gone or not, that transparency was not there. Now today transparency is there, and then everything is automatic. Even the space utilization in the truck, which one to put it first, that also is software is doing. So that is the space utilization with again grid optimization algorithms we have done it. So for a Tata Power, so a lot of data gets